the recording. All right, so we're just going to do some 6.3 and 6.5 problems from the exam list for Mr. C's class. So begin with number 1, which will be they're all partial fractions. So we got 1 plus 6x over 4x minus 3 times 2x plus 5. So what we're going to want to do is use, I believe it's a x plus b over 4x minus 3 plus cx plus d over 2x plus 5. And from there, we are going to make just a and b. Let's see. Okay, yeah, because it's only to the, yeah, it should just be a to the first. Never mind, so this makes it easier then, at least. Yeah, you never know. Let's see, what is the case in which we have to use it? Oh, when you have like x squared underneath plus bx plus c. Yeah. Okay. So then what we're going to do is we're going to get common denominators, which will cancel out. So 1 plus 6x equals a times 2x plus 5 plus b times 4x minus 3, which you just get by multiplying denominator on each side. So you multiply 4x minus 3, cancels that out and that, and then you have to put that extra up there. All right. So then we can just use some of the smart x's, I guess you can call them. So we can set x equal to 5 over 2. So we'll get 1 plus 6, 5 over 2 equals, that cancels out, actually no, it needs to be negative. So that we can cancel out a and we just get b times 4 negative 5 over 2 minus 3. So then we got 1 minus, so that's 30 divided by 2. That'll be minus 15 equals b. This is going to be negative 10 minus 3, which means we get negative 14 equals b times, or negative 13b. So b equals negative 4, or equals 14 over 13 because the negatives cancel. Then we can also do x equals 3 over 4. That way we get 1 plus 6 times 3 over 4 equals a 2 times 3 over 4 plus 5, and then b side cancels out. So from there we got 1 plus, that's going to be 9 over 2. That equals a times 3 over 2 plus 5. And simplify again for 11 over 2 equals a. That'll be 13 over 2. Then we can multiply by 2 on both sides. So and then divide by 13. So 11 over 13 equals a. And then let me just check the answers real quick. Oh, we don't actually have to determine the numeric value of this. Guess it's a little extra then. We just had to determine the form. Okay, then we'll just go on to number 2, which is, or actually, we'll do 1b. I forgot that there's a, and C, or at least A and B. So B is 10 over 5x squared minus 2x to the third. From here, we can factor out an x underneath. So we get x 5. Or actually, we can get x squared out. We can pull an x squared out. That'll be 5 minus 2x. Which means we'll get the form of a over x plus b over x squared plus c over 5 minus 2x. And let's just check that. And that is correct. All right, now we can go on to number 2, in which we just need to find the form. And there is no answer checking on this one. So for A, we got x over x squared plus x minus 2. So that is going to become x over x, let's see, how can we do this? Oh yeah, plus 2x minus 1. And that's going to equal a over x plus 2 plus b over x minus 1. And then we can go on to part 2, or no, part B, which will be x squared over x squared plus x plus 2. And then we can factor on the bottom, so we'll have x squared over x plus 2. Actually, I don't think this is factorable. No, it's not. So we're going to have to instead use the ax plus b. So what we're going to do is we're going to set that equal to a over, no, ax plus b over x squared plus x plus 2. Okay, we can then go on to part C. Actually, wait, no. We might be able to do long division because of that x squared. Let's see. All right, so that means we'll get 1, so that's going to be minus x squared plus x plus 2, which means we're going to get opposite x minus 2 as the remainder. So that means this is going to be equal to 1 plus opposite x minus 2 over x squared plus x plus 2, which means that this will equal 1 plus, or no, and then this fraction right here is going to be equal to a over x, or ax plus b over ax squared, no, over x squared plus x plus 2. Okay, we can now go on to number 3. And 3a is going to be x to the 4th power plus 1 over x to the 5th power plus 4 times x to the 3rd power. So we can first factor, so we're going to have x to the 4th plus 1 over x to the 3rd power times x squared plus 4. And then that is going to be equal to a over x plus b over x squared plus c over x to the 3rd power plus, then, so x squared plus 4, I think that's going to be dx plus f over x squared plus 4. Oh wait, no, can we factor this one more? No, we cannot. Alright, so let me just check the answer real quick. And this is the correct answer. Right here. Okay, now we can go on to part B, which will be 1 over x squared minus 9 squared. So this is going to be, so we can first factor out the bottom. So it'll be 1 over x minus 3, x plus 3. And then all of that is squared. Just really making me wonder if we should first distribute. Let me think. I mean, we can distribute that squared underneath, I believe. So it'll be 1 over x minus 3 squared times x plus 2 squared, which from there we can set it into our partial fractions of a over x plus 3. Why do I have a or x minus 3? Yeah, x minus 3 plus b hello over b over x minus 3 squared plus c over x plus 3 plus d over x plus 3 squared. And let me just check the answer real quick. And we are all good on that answer. Yeah, we got all the fun partial fractions right now that we have to go over. Okay, so oh yeah, the section that this is 6.3 in the book. If I don't know if that's on your exam. Okay. Oh, okay. So you all have like the first part of 7. I think Mr. C just did it in a different order than y'all then, because we got 7.4 through 7.6, but that is those were just we just went over those, but those are also on our exam. Okay. So let's see. Number 4. So for number 4, it's going to be x to the 4th power minus 2x to the 3rd plus x to the 2nd plus 2x minus 1 all over x squared minus 2x plus 1. Okay, so we can probably do some long division here. So we're first going to be able to take out an x, or we're going to be able to take out an x squared, so it's going to be minus. So we take this, multiply it by this, so x to the 4th minus 2x to the 3rd plus x to the 2nd, and then we can subtract, so we get 0, that becomes an addition, so 0, and that becomes subtraction, 0, so that means we just have 2x minus 1 as our remainder. Alright, so now we can rewrite our fraction as x squared plus 2x minus 1 over x squared minus 2x plus 1. And then we can factor the bottom out. So we get 2x minus 1 over x minus 1 times x minus 1. So just x minus 1 squared. Unfortunately, we cannot cancel out any of the top terms, so we need a partial fraction for. So we're going to get a over x minus 1 plus b over x minus 1 squared. So our total form should look like it equals x squared plus a x minus 1 plus b over x minus 1 squared. And I can check the answer. Oh, and I cannot check the answer because it's not a checkable problem. Okay, let's go into part B then. Actually, oh no, he only does odds, so we don't even need to do this one. So we can just go right down to number 5. All right, so for part 5a, we got x to the 6th power over x squared minus 4. So we can factor out on the bottom. So x to the 6th over x plus 2 times x minus 2. And then we'll get that equal to a over x plus 2 plus b over x minus 2. And then we can just check real quick. Oh wait, I forgot to do the long division. So we got to wait a second and actually do the long division. So we got x to the 6th divided by x squared minus 4. Okay, so first we need what can we get that multiplies by x squared to get x to the 6th, and that is going to be x to the 4th. So we're going to have minus x to the 6th minus 4x to the 4th, and that is going to be equal to 4x to the 4th, and then we can bring down a 0. So then what times what gets, or what times this gets x to the 4th, or 4x to the 4th, that is going to be 4x squared. So then we're going to minus 4x squared, no, x to the 4th, minus 16x squared. So then a minus times a minus is going to become a plus, so we have 16x squared right there. And then we can take it out one more time, and then we can do that with plus 16. So in which we can then minus 16x squared minus 4 times 16 is going to be 64. So which means we're going to have 64 as the remainder. So now our statement is going to be x to the 4th power plus 4x to the 2nd power plus 16 plus 64 over x squared minus 4. And then we just can turn this into a partial fraction. So we're going to end up getting x to the 4th plus 4x squared plus 16 plus a over, oh, and then we need to factor it first. So 64 over x squared minus 4 equals 64 over x minus 2 times x plus 2. So x minus 2 plus b over x plus 2. And then that is the correct answer. Okay, and then on to part B. We have x to the 5th power plus 1. Oh, wait, no, I'm reading the wrong problem. We have x to the 4th power, no plus 1, over x squared minus x plus 1 times x squared plus 2 to the 2nd power. So we can just go right into, well, let's see, we might be able to factor this right here. Actually, so x might, nope. No, yeah, no, x might, yeah, no, we cannot factor it. So what we're going to end up getting should be ax plus b over x squared minus x plus 1 plus c over, or no, that should be cx plus d over x squared plus 2 plus fx plus h, no, but that should be g plus g over x squared plus 2 squared. And then we can check the answer. A, B, C, D, E or F or G. It does not matter which one. And that is the correct answer. So now we're going to go on to some integration in this section. Oh, hello, welcome to the call. Let's see, so now we got number 7, which is going to be the integral of x to the 4th power divided by x minus 1 dx. So first we're going to need to divide. So we have x to the 4th on the inside and then x minus 1 on the outside. All right, so we're first going to multiply by x to the 3rd power. So we're going to get minus, so x to the 3rd times x is going to be x to the 4th minus x to the 3rd. We're going to minus and add. So this becomes 0. This will become x to the 3rd, which means we're going to need an x to the 2nd. And we're bringing down a 0. So we're going to minus x to the 3rd. Well, on the inside of the bracket, it's going to be x to the 3rd minus x squared, which minus right there, add this, so it'll become x squared on the bottom, which means we're going to need an x. So we're going to have minus x minus x. We're going to have x squared minus x, which means we're going to get an x on the bottom, and then we can get 1 also out. So we're going to minus x minus 1, which means 1 is going to be our remainder. So our new fraction is going to be, so we're going to have the integral of x to the 3rd power plus x to the 2nd power plus x plus 1 plus 1 over x minus 1 dx. So 1 over x minus 1 will be our partial fraction. And actually, let me use another color for this. And that is going to equal a over x minus 1. Multiply out on both sides, and we're going to get a equals 1, 1, I believe. Oh, no, we don't. No, that's actually factorable. We don't even need to do that. That is pointless. Because we can just use a u substitution right there. So instead, we're going to get, we're just going to break up these intervals. We'll just integrate the first part and then leave this out on the end to integrate right after. So we are going to get x to the 4th over 4 plus x to the 3rd over 3 plus x to the 2nd over 2 plus x plus the integral of 1 over x minus 1 dx. We are going to set u equal to x minus 1, and that means du is going to equal dx. So that'll be the integral of 1 over u du, which means that we are going to get ln of u. Over here, I'm going to write it out this way. Plus c, which is going to equal to ln x minus 1 plus c. So we are now going to write this out as x2. Oh, and also I forgot to put, no, we don't need to put it where it's evaluated to because we're finding a indefinite. All right, so we're going to get x to the 4th plus x to the 4th over 4 plus x to the 3 over 3 plus x to the 2nd over 2 plus x plus ln x minus 1 plus c. And then let me check the answer real quick. And the answer is correct. So this right here is the answer to number 7. So now we can go on to number 9. For number 9, we are going to have x, 5x, or the integral of 5x plus 1 over 2x plus 1 times x minus 1 dx. Okay, so we are just going to set up our partial fraction, which will be 5x plus 1 over 2x plus 1 times x minus 1, and that is going to equal a over 2x plus 1 plus b over x minus 1. Then we're going to cancel out the denominators, so we're going to have 5x plus 1 equals a times x minus 1 plus b of 2x plus 1. And with this, it's simply just, I would take this, just move it up, take this, move it up, because it cancels out that way. So then we're just going to pick some good numbers for x. So we're going to set x equal to 1. So we're going to have 5 times 1 plus 1 equals, a gets canceled out, so we're going to have b 2 times 1 plus 1. So this is going to be 6 equals b times 2 plus 1, so that's 3. So b is going to equal 2. And then we can also input negative 1/2 in to cancel this out. So we're going to have x equals negative 1 over 2. So 5 times negative 1 over 2 plus 1 equals, b is going to get canceled out, so we're going to get a opposite 1 over 2 minus 1. So that is going to be opposite 5 over 2 plus 1 equals opposite 3 over 2a. This is going to be opposite 3 over 2 equals opposite 3 over 2a. 2's are going to cancel out, the 3's are going to cancel out, and the negatives are going to cancel out. We're going to get, oh yeah, and yeah, yes, I will be uploading a video of this. Yeah. So a should equal 1. I would put yes in the chat, but let me see if there's an emoji that says yes or something. Oh, I should work. Okay, so from here, we can now rewrite our integral in terms of the partial fraction. So we are going to get, because a equals 1, so it'll be 1 over 2x plus 1 plus b equals 2, so it'll be 2 over x minus 1 dx. So from here we can split this into two integrals. So we're going to have 1 over 2x plus 1 dx plus the integral of 2 over x minus 1 dx. So for this first one, we're going to do a u substitution, in which u is going to be equal to 2x plus 1, du is going to equal to 2 dx, so du over 2 is going to equal to dx. So we're going to get the integral of 1/2, we're going to take that out to the front, 1 over u du, plus, and I'll use green over here, so we're going to put u equal to x minus 1, du equals dx. So this will be the integral of 2, the integral of 2 times the integral of 1 over u du. So then we can integrate. So this is going to be 1/2 ln of u plus 2 times the ln of green u plus c. And then we can just simply substitute back in our purple and green u's. So it'll be 1 over 2 ln of purple u, which is going to be 2x plus 1. And we need to keep our absolute value, plus 2 times the ln of green u, which is x minus 1. Again, need to keep the absolute value, plus c. And then we can check the answer real quick. So 1/2 ln of 2x plus 1 plus 2 ln of x minus 1 plus c. And that is the answer for number 9. All right, time to go to number 11. Here I will just show all the work real quick. Okay. So for number 11, we have the integral from 0 to 1 of 2 over 2x squared plus 3x plus 1 dx. All right, so we're going to have to begin by writing out our partial fraction, and we cannot simplify this denominator. We cannot factor it. Actually, wait. We might be able to. Let me see. So 2x plus 1, and then x plus 1. So that'll be 3x on the inside, the 1x out there. Actually, yeah, we can factor it. So we're just going to rewrite this as the integral of 0 to 1 of 2 over 2x plus 1 times x plus 1 dx. All right, so now we're going to take our partial fraction and solve for it. So we're going to have 2 over 2x plus 1 times x plus 1 equal to a over 2x plus 1 plus b over x plus 1. Then we're going to cancel out the denominators. So 2 is going to be equal to a x plus 1 plus b 2x plus 1. And then we're going to use some smart values of x. So we're going to first set x equal to negative 1. So we're going to get 2 equals, we're going to cancel out this first part, so it's going to be b times 2 times negative 1 plus 1. So 2 equals, so that's going to be negative 2 plus 1, that's going to be negative 1, so negative 1b. So b is going to equal negative 2. Then we can also put in negative 1/2 for x also. So we're going to put x equal to negative 1 over 2. So we're going to get 2 equals a negative 1/2 plus 1 plus, and then that b is going to be a 0, so we don't have to write it. So we're going to get 2 equals 1/2 a. A is going to equal 4. All right. From there, we can substitute this back into our integral. So now we're going to have the integral from 0 to 1 of 4 over 2x plus 1 plus negative 2 over x plus 1 dx. And that integral looks pretty poor. I'm just going to rewrite it. All right, so then we're going to split it into two integrals. So we're going to have the integral from 0 to 1 of 4 over 2x plus 1. And then we're going to have the integral from 0 to 1 of opposite 2 over x plus 1 dx. And then we will just bring the 4 and the 2 out to the front just to make it a little easier to work with. And don't forget the dx's. All right, so we could do these substitutions, but we did do it a couple of other times further up on the previous problem. So I am just going to kind of skip over those steps. So this is going to be 4 over 2 ln of 2x plus 1 minus 2 ln of x plus 1. And then all of this is going to be evaluated from 0 to 1. Okay, so we can factor a 2 on the outside, so I'm just going to write it as 2 ln of 2x plus 1 minus the ln of x plus 1 from 0 to 1. Just that way it's a little easier to work with. So we're going to get 2 times, we're going to evaluate it at 1 first, so ln of 3 minus the ln of 2 plus ln of 1 minus the ln of 1. So the ln of 1's will cancel out, so we're going to end up with 2 times ln of 3, which we could use parentheses now, minus ln of 2. And then let me just check the correct answer, which the textbook simplifies this to being 2 ln of 3 over 2. But this is also acceptable for the exam, or should be according to Mr. C and how he's done it in the past. All right. So from here, let's move on to number 13. So number 13 is going to be the indefinite integral of ax over x squared minus bx dx. So a and b are going to be assumed to be constants. So let's first factor. So we're going to have the integral of ax over x times x minus b dx, in which our x's will cancel. So we're going to get the integral of a over x minus b dx. And it's just going to be easiest to do a u substitution here. So this is going to be equal to a ln x minus b plus c. And then we can just check the answer. A times ln of x minus b plus c is the correct answer. So 13 is nice and easy, just a nice u substitution with constants. All right, time for number 15. So number 15 is going to be the integral from 0 to 1 of 2x plus 3 over x plus 1 squared dx. So first we're going to have to set up our partial fraction. So it'll be 2x plus 3 over x plus 1 squared. And we're going to set that equal to, well, let's see. We should be able to get away with a over x plus 1 plus b over x plus 1 squared. All right, then we can cancel out the denominators. So we're going to get 2x plus 3 equals a times x plus 1 plus b. So from here we can use a select value of x to solve for this first one. So let's set x equal to -1 so that we can get b. So we have 2 times -1 plus 3 equals b. So that means we're going to get -2 over here plus 3, so 1 equals b. And what we can just do is we can sub b back in at 1, and we can do any other number. So we'll just do x equals 1. So we're going to have 2 times 1 plus 3 equals a 1 plus 1 plus, and then we're just going to take this right here, 1. All right, that is going to be 5 equals 2a plus 1. We can subtract 1 from each side, so 4 equals 2a, and a is going to then equal 2. All right, then we can rewrite our integral. Let's use gray here. So we're going to have the integral from 0 to 1 of 2 over x plus 1 plus 1 over x plus 1 squared dx. So we're going to split this into two integrals. So we're going to have the integral from 0 to 1 of 2 over x plus 1 plus the integral of 1 over x plus 1 squared dx. Oh, from 0 to 1. So factoring the first one is going to be easy enough to use substitution, and we're going to have to use substitution by parts for the second one. Or actually, wait. No, we don't. We can just do another use substitution, except I will write that one out. So let's first just do the one on the left. So it's going to be 2 ln x plus 1 from 0 to 1 plus, now let's get our u substitution, so we're going to set u equal to x plus 1. That means du is going to be equal to dx. So we're going to have the integral from, well, we're just going to use from alpha to beta of 1 over u squared du. Okay, so we're going to have 2 ln x plus 1 from 0 to 1 plus, so then we can now integrate this. This can also be written as the integral from alpha to beta of u to negative 2 du. So this is going to be plus u to the, or let's see, negative 3, 1, u to the negative first power plus c. And this is going to be evaluated from alpha to beta. So then we can sub our u back in. So we're going to end up having 2 ln x plus 1 minus 1 over x plus 1 plus c. Actually, no, plus c because we don't need the plus c on this one. And all of this is going to be evaluated from 0 to 1. All right. So then now we can plug in our numbers. So we're going to have 2 ln of 2 minus 1 over 2 minus 2 ln of 1 minus 1 in parentheses. And then we can simplify. So it'll be 2 ln of 2 minus 2 ln of 1, which I believe ln of 1 is 0. And then let's just get this real quick. So that's minus, and we have to distribute that minus, so that becomes a plus 1 over 2. So it should be 2 ln 2 plus 1 over 2. And then let me just check the answer real quick. So 2 ln of 2 plus 1 over 2 is the correct answer for number 15. All right. Let's go on to 17. And today might just be a 6.3, and I'll just do one every other day leading up to the exam for each section, just because there's a lot of problems listed. So number 17, so it'll be from 1 to 2, or the limit of from 1 to 2 of 4y squared minus 7y minus 12 over y times y plus 2 times y minus 3. So we know this is going to be y third on the bottom, y squared on the top. So we will be all good to set up our partial fraction. All right. So 4y squared minus 7y minus 12 over y times y plus 2 times y minus 3. We're going to set that equal to a over y plus b over y plus 2 plus c over y minus 3. And now we're going to cancel out the denominators. So we're going to have 4y squared minus 7y minus 12. That is going to be equal to a times y plus 2 times y minus 3 plus b of y times y minus 3 plus c of y minus 3 times y. All right, so now we can place in some values of y to make this easier. So the first one that comes to mind for me is y equals 0, because it will cancel out all this. So what we're going to, and all this, so what we're going to get is negative 12 equals a times 2 times negative 3. So we're going to get negative 12 equals negative 6a, so a is going to be equal to 2. Then I think we can set y equal to, oh, I think I wrote this one wrong. This is supposed to be plus 2. Y equal to negative 2. So we're going to have 4 times negative 2 squared minus 7 times negative 2 minus 12 equals, A is going to cancel out, and we're just going to have B. So B times negative 2 times negative 2 minus 3. All right, so we're going to have 4 times 4, so 16, because the negative cancels, minus, or actually that's going to become a plus 14 minus 12 equals. So this is going to be negative 5 times negative 2, so that is going to be 10b. All right, so this will be 30 minus 12 equals 10b. So we take 30 minus 12, that is going to be 18 equals 10b. So b is going to be equal to 9 over 5. Okay, now let's see. We can also set y equal to 3. And I am just going to, I guess you can say, make them noticeable so I can go back to them later. Okay, so we're going to have 4 times 3 squared minus 7 times 3 minus 12 equals, our a is going to cancel out and b is going to cancel out. So we're going to be left with c times 3 plus 2 times 3. So 3 squared is going to be 9, so we're going to have 9 times 4, which is equal to 36, minus 3 times 7 is 21, minus 12 equals, you're going to have 5 on the inside, so 5 times 3 is going to be equal to 15c. All right, so we can clean this up a little bit. So this is going to be 33 over here, so 36 minus 33. That is going to be equal to 3, equals 15c. So 3 over 15 is going to be equal to c. All right, so now we can rewrite our integral, which I will use purple. So we're going to have the integral from 1 to 2. So our a is equal to 2, so we're going to have 2 over y plus our b is equal to 9 over 5. So 9 over 5 times y plus 2 is on the bottom. Plus, and then we have 3 over 15 for c. So 3 over 15 times y minus 3 times dx. Or actually dy in this case, not dx. Yeah, I wrote that wrong. All right. So now we can integrate this first one. So this is going to be 2ln of y plus, and then we can integrate all of these right away. So 9 over 5 ln of y plus 2 plus 3/15 ln y minus 3. All of this is going to be evaluated from 1 to 2. Okay, so we're going to have 2 ln 2 plus 9 over 5 ln of, so we have 2 plus 2, so that's going to be 4, plus 3/15 ln. So we're going to have the ln of 2 minus 3, so that's going to be negative 1. This is all going to equal 0 because you're taking the absolute value. Then that's going to be minus. So 2 ln of 1, that's going to be 0, so we can get rid of it. Plus 9 over 5 ln of 3 plus 3 over 15 ln of negative 2, so that's going to become positive 2 because of the absolute value. So we're going to rewrite this. So we're going to have 2 ln 2 plus 9 over 5 ln 4 minus 9 over 5 ln 3 minus 3 over 15 ln of 2. And then we can simplify this up a bit. So we're going to have 9 over 5 ln of 4 minus 9 over 5 ln of 3. And then what we're going to have to do is get common denominators. So 2 times 15 is going to be 30. So it's going to be 30 minus 3, so that's going to be 27 over 15 ln of 2. And then let's just check the answer real quick. Okay, so 27 over 5. Did I do something wrong for ln of 2? And then I think I did something wrong in the problem, which we now need to go and find. Because these are, I mean, I guess they may have simplified these in the problem, but they're still quite a bit far off. So back up to this part where I messed up somewhere. And make sure I copied everything over correctly. Y plus 2, y minus 3, dy. Okay. All right, so let's check. Hey, when we set y equal to 0, so that's minus 12 over here. That's going to be 2 times minus 3. Okay, A looks correct. When we set y equal to minus 2, we had the 4 times 4, so that's 16. We had the 7 times 2, which, oh yeah, 7 times negative, or negative 7 times negative 2, that's okay. 12, okay. The b negative times negative 2 right there, that's okay. And the negative 5 right there, okay. Those cancel it out right there. 16 plus 14 minus 12, that's 30 minus 12, so 18, okay. I think that one is fine right there for that one. And then let's take a look here on y equals 3. So 4 times 3 squared. Okay, so that is, so 9 times 4, 36. 7 times 3, 21. Minus 12 stays the same. So y plus 2 right here. Yep. So 3 plus 2, so that's going to be 5 times 3, 15. So 36 minus 21, that is going to be 15 minus 12, so that should be 3. Because the answer that I'm supposed to be getting is 27 over 5 ln of 2 minus 9/5 ln of 3, or this could also be 9/5 ln 8 over 3, and I did not get that. Looks like, was there supposed to be a 5 times 5 somewhere that canceled this out? Four was taken from here, here, y plus 2. Yeah, maybe I should check over here first. So we had So a was y, so 2 over y plus 9 over 5, let's see, b, 3 over 15, y minus 3. If anyone by any chance notices what I did wrong, let me know. If not, there's always a slight chance the textbook's wrong, but that's not normally the case. But it does happen. Hmm. 2 ln y, ln, okay, all right. I mean, I guess I always could try writing it out and seeing what OneNote gets when it integrates, which is just a little cool feature of OneNote. So the integral was from 2 to 1 of 4y squared minus 7y minus 12 over y times y plus 2 and then y minus 3 dy. And then select. Let's see, if I'm lucky, it'll just be nice and easy. And no, we need to fix parts of it. Hmm. Well, the ln of, that's why we take the absolute value of it. Yeah. Um, so I don't think that was the issue because this ln of 3, this y minus 3 right here is going to guarantee we have to take ln of negative numbers, but it just gets absolute valued out. So let me try this one more time. Maybe it doesn't like the fact that I wrote the 7 in 2 pieces. Oh, and look at that. Perfectly did it. So differentiate with respect. Oh wait, no, we want the integral. We want it to be evaluated. Hmm. I mean, at least it's picking up on it, but okay, so I think I had to have done something wrong because it's supposed to be saying it's getting it over 5. I am not getting it anywhere close to negative. Well, I mean, even then, that kind of got a little weird with that 3. Um, oh no, that's right. Right up there, I guess. Unfortunately, it doesn't show me the steps, but I know I did something wrong. Whether that was up in plugging in values or integration. But it looks like it's a value, so it's an issue somewhere with y equals, like when I plugged in y equals 3 right here. Because 4 times 3 squared. 3 squared is 9. 9 times 4, 36. Minus 7 times 3. That should be 21. Minus 12. That should be 3 over here. Okay. And C, let me just make sure I found the right thing for C. So that should be y times y plus 2. So 3 plus 2. So that's going to be 5 times 3, 15. 5, 15 on each side, which does not really go anywhere. Okay, so I'm just going to, because I want to move on to the next problem a bit, but I know somewhere right here I messed up. Everything else looks like it lines up pretty well-ish, even though this should not exist either. So maybe I messed up somewhere up here when I was distributing. Because for a, y plus 2, y minus 3, that all came from there. Y times y minus 3. Wait for B, yep. And then for C, it was those two. I'll be honest with you, I don't know where I messed up. I might go and revisit this. Oh, try reducing the 12 divided by 15. I mean, like, we cannot break it down any further because of the fact that it's not divisible by 5. Unless you mean something else, Ethan. Oh, and that's probably part of the issue. Okay, maybe I'm just being, well, I could be being a bit stupid. Yeah, you are right. Oh. Who knows, maybe I actually had the correct answer the entire time. I was just unable to do basic division. So 27 divided by 3, that equals 9 over 5 ln of 2. Okay, so then comes into the issue of how do we deal with these? Because it's still not technically lining up to one of the correct answers. I mean, if we take a 9/5 out to the front, we get ln of 4 minus ln of 3 plus ln of 2. Unless I got something wrong for this ln of 4 right here, if I follow it up. Two plus 2 is 4. It's like that. Y plus 2, I believe that should be, yeah, y plus 2. Hmm. Yeah, because these all have to be ln's. Huh. I am just curious. Maybe this is another way to write it? That is always a chance. You know what? I think I might just plug this into my calculator. Maybe I got something wrong. Is around 1.90. While this one, which we were getting earlier, is around, yeah, I did something wrong, I think, 1.765. Okay, I think I'm going to move on to the next one, because somehow I'm not getting this inside value high enough for 4, like that should be an 8 according to the solution, or somehow you have to get an 8. And even then, this is kind of going a little weird, so unless I messed up on one of the other sections, but I'll just kind of skip over 17 and ask him during office hours because I do not know what I did. Okay, let's go on to, let's do number 23, and then we can do a challenge problem or two and try to get through it. If not, well, I'm definitely going to be asking him in office hours for some of these. I think I'll call it after that, as that will be around an hour and a half. So I'll just try to do another session each day just so I can refresh my brain and hopefully everyone else's. Everyone can enjoy the pain. Okay, so with this, we can't do anything with the top, so what we are going to have to do is set up our partial fraction. So we're going to have 10 over x minus 1 times x squared plus 9. And we cannot factor this. So we're going to have to set this equal to a over x minus 1 plus bx plus c over x squared plus 9. We can cancel out the denominators. We got 10 equals a times x squared plus 9 plus b x plus c times x minus 1. So before we go and actually start factor this out, because we're going to have to do that, I want to just deal with finding this a value, which we can get by setting x equal to 1. So we're going to have 10 equals a, 1 plus 9, so a is going to be equal to 1. Nice and easy. Now we need to factor out, or no, not factor out, distribute. So we're going to have 10 equals a, x squared plus 9 plus bx squared minus bx plus cx minus c. And then we should be able to take a c and a b out from each part. So we're going to have 10 equals a, x squared plus 9, plus bx, x minus 1, plus c, x minus 1. Okay, so if we set x equal to 0, we will be able to get rid of this, the bx, and we should be able to solve for c, and we'll just drop down our 1 for a. So we're going to have 10 equals 1 for a, times 9 plus, since, oh, let me put x equals 0 right here. This is going to be 0 plus c times negative 1. So we're going to get 10 equals 9 minus c. So we're going to subtract that 9 over, so we're going to have 19 equals negative c, and so c, actually no, we minus both sides, so that'll be 1. So negative 1 equals c. Oh, 7.6, yeah, we need to review 7.6 before the test, definitely, and I would say 7.4 is also pretty hard. It needs a good review. Or actually, I think that was one of the more. I don't know. I don't remember. I think 7.5 was it, or no, 7.4 was a little bit more complex. I could be just remembering wrong, and I might be listing the wrong one. All right, so now we're going to have to solve for b, which we can just choose any value except 0 or 1. So let's pick 2. So x equals 2. So we're going to have 10 equals a times 2 squared plus 9 plus, I'm just going to use this problem up here as we're already substituting in for a and b, and a being 1, or no, a and c. So plus our bx is going to be b times 2 minus 1, 2 minus 1. Okay. Yeah, it might have been 7.5 for arc length. Even though that wasn't too bad. Honestly, I think that now that we got the first half of integration done, like learning the in the first part, I think the rest of the units are going to be a lot easier. It's not like they're crazy. So we're going to get 10 equals 4 plus 9 plus 2b minus 1 times 1. So we're going to get 10 equals 13 plus 2b minus 1, which will be 10 equals 12 plus 2b. We'll just divide by 2 on both sides, so 5 equals 6 plus b. So negative 1 will equal b. Okay. So now that we got those, it's time we rewrite our integral for 23. So now we're going to have the integral. So our value for a is 1, so 1 over x minus 1 plus, then we have b plus c. So our b is negative 1 and our c is negative 1. So opposite x minus 1 over x squared plus 9 times dx. All right, from here we can split our integral into two parts. So I'm just going to integrate this first part, which is going to be ln of x minus 1, the absolute value, plus, and then we're going to have the integral of opposite x plus 1 over x squared plus 9 dx. And let's see, can we u substitution this? No, we can't, because if we set u equal to this, we're going to end up getting, let's see. So u equals x plus 1, du equals dx. Oh, wait, no, we need x squared. So x squared plus 9. du is then going to equal 2x dx. This one we might need to do by parts. Let's split the numerator into two. Oh, yep. Oh, you mean like creating like one of the splitting, creating a square type thing? So what I'm okay. Oh, okay. I see what you're meaning. So x over x squared plus 9. Yeah. Oh, yeah. Because we can then split that into two different ones because it's the numerator. All right. Well, that makes this left side very easy to use substitution, and then the other one I think we're going to have to do by parts. So for this one, we're going to set u equal to x squared plus 9, which will mean du equal to dx, which means du over 2 is going to be equal to dx. And we're going to split this into two intervals. So we'll bring down our ln of x minus 1 minus So this is going to be the integral of 1/2 1 over u plus, so here we have the integral of 1 over x squared plus 9. Well, that almost looks like tangent. Let's see, so what is it? Tangent squared theta plus 1 equals secant squared theta. Yeah, this looks like it's going to be one of those type of problems, which will probably save us some time. So if we set x equal to, actually no, it's because it's the, hmm? Remember my formulas? Let me think. Because that is 3 tangent inverse of x, or I don't think. Wait, no, that doesn't make sense because you can't just pull that out from the front. Wait, no, I think I can, if I remember correctly. Except I think that, because if I remember, it was 1 over a squared plus x squared, tangent inverse. I don't remember if it was 1 over x in the front, though. It was either 1 over a, or it was just a in the front. I think it was just a. Ethan, does that look around right? The formula right here? To square both oh, wait, to square both numbers? Oh, the square on both numbers. Squares. Oh, yeah, because that's, so so this is going to be equal to 3, so this is pretty much 3 squared. Remember if it was, I'll be honest, I do not remember the formula. I'll probably need to look it up. Not good, I know, but I definitely need to rememorize this one. Yeah, this is 1 over a, I think I remembered the formula correctly initially. 1 over a x over a. Um, yeah, this is the correct formula, and then it's plus c. All right, so guess I should trust myself a little more with that. Because that saves a good amount of time. So that's going to be plus because that's already integrated, we're just going to put in 1/3 of tangent inverse of x over 3. And then because we integrated everything, we're going to add plus c to the very end. So now we're going to get the ln of x minus 1 minus 1/2 of ln, and we'll just substitute back in for u. So we're going to get x squared plus 9 plus 1/3 tangent inverse of x over 3 plus c. And then we can check that answer real quick. I think this is 23. Yep. Uh, ln of x minus 1 minus 1/2 ln x squared plus 9 minus. Oh, it's a minus 1/3 right there. I guess it's supposed to be a minus up here then. That's the only. Oh no, because it's distributed. I forgot to distribute this sign to both. Plus c. All right, so this is the correct answer right here. Just don't forget to distribute and remember the tangent inverse formula. Okay, let's go into a couple of the challenge for this section, which are probably going to be painful, but they are going to be worth it in the end. Okay, so the first one is going to be 39. So 39 is going to be the integral of e to the 2x over e to the 2x plus 3e to the x plus 2 dx. If I remember correctly, he did this one in class on one of the days, but now we're here to do it, so might as well. Okay. Trying to see if we can factor out on the bottom. It does not look like we can. Because this would be e to the x. Oh, we might be able to. So that's e to the x plus 2 times e to the x plus 1. Because that'll be e to the 2x right there. So 2, 3. Okay, yeah, actually we can. So we're going to have e to the 2x on top over e to the x plus 2 times e to the x plus 1. And that's going to be the integral dx. All right, from here we need to set up our partial fractions. So we're going to have e to the 2x. Actually, I'm going to use a different color for the whole partial fractions on this one, just for organizational sake. So e to the 2x, which we can just write as x, e to the x squared over e to the x plus 2 times e to the x plus 1. And that is going to be equal to a over e to the x plus 2 plus b over e to the x plus 1. All right. From here, we're going to cancel out our denominators. So we're going to have e to the x squared equals a times e to the x plus 1 plus b times e to the x plus 2. And then we can say what value will cancel out. Well, we can't cancel out with that, so because e to the 1 is just going to be e to the 0 is going to be 1. Catch 22 right there. I think we might need to possibly... Oh yeah, they are the same degree, which means we have to do long division first. So, all right, I guess long division. And I mean, we can take one thing out. So to the x squared plus e to the x squared plus 3e to the x plus 2. Oh, as long as you, no long division u sub. Okay, here, let's take a look then. Let's see what you're doing, because that's probably easier than just doing a giant u sub. So you're saying set u equal to e to the x, which du is going to equal to e to the x dx. And then let's do our partial fraction from there. So, oh, okay, I see what you mean. So on top, we're going to get e to the x times e to the x over e to the x squared plus 3e to the x plus 2 dx. So we're going to set these two equal to this, and everything else will be in terms of u. So we'll take the integral of u du over u squared plus 3u plus 2, which that will equal u, or the integral of u du over u plus 2 times u plus 1, and then, yeah, that saves the entire having to do long division with e to the x's. Thank you, Ethan. All right, so from here, we can do our partial fractions, which I will instead do in purple now. Oh, and I forgot the du. Oh, I already put the du, never mind. So we'll have u over u plus 2 times u plus 1. That's going to be equal to a over u plus 2 plus b over u plus 1. Okay, so we're going to cancel out the denominators. So we're going to have u equals a times u plus 1 plus b u plus 2. So we're going to begin by setting u equal to -1 to get rid of the a. So we're going to have -1 equals b, -1 plus 2. So that's -1 is going to equal b. And then we can set u equal to -2. So we will get -2 equals a, -2 plus 1, and then b's cancel out because it's 0. So they don't cancel out, they're just equal to 0. So that'll be -2 equals -a, so a equals 2. So our new integral is going to be from 2 over u plus 2 plus, actually it's going to be -1 over u plus 1 du. And then when we integrate, we're going to get 2ln u plus 2 minus ln of u plus 1 plus c. Let's just make sure that this is correct for 39. Oh, and we need to substitute back in for u. So let's see, what did our u equal again? E to the x. So this is going to be 2ln e to the x plus 2 minus ln e to the x plus 1 plus c. And I am getting an inconsistency with the book. Oh no, okay, never mind. So the book, what the book did was it took this 2, the power, and put it on the inside to the power, so that's e to the x plus 2 squared minus ln e to the x plus 1 plus c, and then because of the minus, it was able to divide. So we had ln e to the x plus 2 squared over e to the x plus 1 plus c for the book. All right, let's go on to 41. And also here, I'll just show all the work for this real quick. It's actually not that bad after you get rid of that e to the x, so thank you, Ethan, for recommending the u substitution. And I think I remember doing that in class now. Unfortunately, that's not going to help on the test when I forget. All right. So how are we to address this one? So I might try factoring first. So that'll be ln of x minus 1. No, x minus 2. No. Is this factorable? Let's see. No, it does not look to be factorable. Makes it a little bit harder to do. Okay, so we're going to have to do integration by parts here. Well, I mean, it did say to use integration by parts, but this is really, it looks like a lot. So I guess we can set u equal to x squared minus x plus 2. And then we can set dv equal to ln of x. Because when we integrate that, we get 1 over x, and when we take the derivative of this, we get 2x minus 1 dx. And then we can use the integral u dv equals uv minus the integral of v du. Okay, so we're going to have set this all is going to be equal to x squared minus x plus 2 times 1 over x minus the integral of 1 over x times du, so that's going to be 2x minus 1 dx. Okay, so that's going to be equal to x squared minus x plus 2 over x minus, so that's going to be 2x minus 1 over x dx. We're going to be able to split that into two different integrals. So x squared, well, actually we can even simplify an x out over here. So x minus 1 plus 2 over x minus the integral of 2 dx minus the integral, well actually this will be plus because we have to distribute that minus sign, 1 over x dx. Okay, so that means we get x minus 1 plus 2 over x minus, so this will be 2x, and this will be plus ln x plus c, and then we can simplify a little bit. So this will be opposite x, or we'll begin with 2 over x. 2 over x minus x minus 1 plus ln x plus c. And let's just check the answer real quick. Okay, they wrote the answer very different, which is kind of concerning, because they even got a tangent inverse here. Unless I just got lucky, because let's see, L-I-T, yeah, I think they used set u equal to the ln. Because their answer was x minus 1/2 times ln of x squared minus x plus 2 minus 2x plus the square root of 7 tangent inverse 2x minus 1 over root 7 plus c, which is very different than this. Guess there's always trying to set L equal to, or unless, I might actually not have been able to take this out like I did like this, because this is technically not multiplied and it's within. Yeah, I think that's what I did wrong. Okay. So let me rewrite it. So instead what I think is supposed to happen is it's first going to be, we're going to set u equal to the ln x squared minus x plus 2, and then we're going to set our du equal to the derivative of that. So that is going to be, what's the derivative of ln of x? Because if the integral of that is let's see, 2x minus 1 divided by x squared. Oh yeah, I forgot this is the derivative, and because ln of x is equal to wait. Yeah. So wait, 2x minus 1. That looks like it's coming from the chain rule right there, over x squared minus x plus 2. Oh yeah, because wait, so is the derivative of ln just 1 over x? Okay. I think I was just having a brain fart moment, I guess you can say. Yeah, that makes sense. And then we're just going to set dv equal to dx, and then v equal to x. Okay. So from here, we can then use the integral of u dv equals u times v minus the integral of v du. So this is an integral. I forgot the integration sign. So we're going to get ln x squared minus x plus 2 times x minus the integral of v, which is going to be x, times du. I forgot that dx right there. Times 2x minus 1 over x squared minus x plus 2 dx. Alright, so this is going to be equal to ln times the absolute value x squared minus x plus 2 times x minus the integral of 2x 2x squared minus 1 over x squared minus x plus 2 dx, and which we can use long division, and then probably followed by partial fractions. Because let's see, yeah, we need to do some long division. Yeah. So we have 2. I'll grab another color for this pen. 2x squared minus 1, so plus 0x minus 1. And then we have x squared minus x plus 2. Okay, so we're able to take out 2. So that's going to be minus 2x squared minus 2x plus 4. And then we actually have to make the minus, it's a subtraction. So that was going to be 0 minus 2, no, plus 2x minus, so 1 minus 4 is minus 5. So this will be our remainder. Okay, so this now gives us our partial fraction, or no, our fraction plus the what we were take out, so 2 plus 2x minus 5 over x squared minus x plus 2. Okay, and then from there we're going to have to take a partial fraction of this. Since we cannot factor out anything on the bottom, it's going to be equal to 2x minus 5 over x squared minus 4 plus 2, no, minus x plus 2. That'll be equal to a x plus b over x squared minus x plus 2. If we just cancel out the denominator, we get 2x minus 5 equals ax plus b. Alright, so first let's set x equal to 0. When x equals 0, a is going to be non-existent, so negative 5 equals b. Okay, that was nice and easy. Then we can set x equal to 1. So we're going to get 2 times 1 minus 5 equals, we can substitute back in our value for b. Well, no, actually, we're going to have a times 1. Then we substitute our value in for b, which is minus 5. So we're going to get 2 minus 5, so negative 3 equals a minus 5. So a is going to be equal to 5, 6, 7, 8. All right, so now we can go back to our integral, which we're going to pull down. So it's going to be equal to the ln x squared minus x plus 2 times x minus the integral of 2 plus, and then we have our partial fraction over here, which is going to be 8x minus 5 over x squared minus x plus 2 dx. Okay, so we're going to have this equal to ln of the absolute value of x squared minus x plus 2 times x minus, so the integral of 2 is going to be 2x plus, looks like we're going to have to do a u substitution for this second part. So let me grab another color here. So let's set u equal, oh here, I'm just going to write out this 8x minus 5 over x squared minus x plus 2 dx. Okay. So when we set u equal to x squared minus x plus 2, that means we can get du equal to 2x minus 1. Okay, now we just need to get this equal to, see if we can get an x to the minus 1 up here, or 2x minus 1 dx. Okay, so I'm just going to rewrite this one more time. So ln x squared minus x plus 2 times x minus 2x times the integral. How can I get x minus 1 up here? I guess I could complete the, well, not really complete the square, but create a plus and then a minus. So we can have 8x minus 5 minus 3 plus 3 over x squared minus x plus 2 dx, which then can be rewritten So the integral becomes the integral of 8 times x minus 1 plus 3 over x squared minus x plus 2 dx. So this integral will then be split, and we're going to be able to use our u substitution that we have right here. So now we're going to, this equals ln x squared minus x plus 2 times x minus 2x minus. So when we do the u sub, it's going to be minus, well, here I'll write it out. So this will become the integral of 8 times, actually that should be, I did not add correctly above. All right. Oh, see you, Ethan. Because I need this to be 2x out in the front, and we have 8 right there, so we're going to need a lot more than 3. 3, 4, 5, no, 8, 9, 10, 11. It should be 11 that we need. Because that'll give me 16 there. No, I think, I think I may have been, need to add 1. So this will be minus 4 minus 1. Because then I can take a 2 out, or I can take a 4 out. Then it'll give me 2x minus 1 minus 1. Okay, that is what I did wrong. Okay. And then that gets split into the integral of 4 times 2x minus 1 over x squared minus x plus 2 minus the integral of opposite 1 over x squared minus x plus 2. And then dx on both. Okay. So that means we get ln x squared minus x plus 2 times x minus 2x minus, we will distribute that along with doing our u sub. So minus 4 times the integral of du over u, and then we have to distribute this over here, so then it'll be plus, and then this minus also comes out, so because we have 3 minuses, it will stay a minus the integral of 1 over x squared minus x plus 2 dx. Okay. So I think we'll just do partial fractions off to the side on this one. So we have the integral of 1 over x squared minus x plus 2 dx. We can set our u equal du, our v, and our dv. We can set our dv equal to dx, so that we can just get x for our v. And that means we can set u, or actually, let's see. Yeah, I think we're going to have to do that. So dx, x, u will equal 1 over x squared minus, no, that doesn't. We set our u equal to x squared minus x plus 2? Let's see. Honestly, I don't know. I'm a bit lost on this problem. I don't think I did something right somewhere. So I think I'm just going to ask him number, let's see, which were the ones that were causing me issues? Okay, so number 17, and then number 41 during office hours, as I really, either my brains just can't think right now or whatnot, just not there. I do not know what I'm doing wrong. All right, so I'm going to call it that for today on the review session for just 6.3 partial fractions. So stopping the recording.